Hi guys, this is section 4.6 part 2, which is solving absolute value inequalities. So part 1 was solving absolute value equations. Part 2 we're going to do inequalities. There are two types of inequalities. There's going to be the less than, which is the and problems, and the greater than, which is going to be the or problems. Okay, one way to remember it is they rhyme. Less than, and, greater, or. Okay, and they are very different, and you'll see when we get there. So if I have this problem, and I'm going to try to keep it to green and red, and try and remember to color code it for you. If I have absolute value of n is less than 3, what this is saying is all numbers less than 3 units from 0. So remember when it was an equal sign, it was all numbers exactly 3 units. So this one, because it's an inequality, is going to be less than 3 units. So when you come here, it's actually going to be all numbers less than 3 units from 0, which is our and problem, and it's going to be between the two, which is our rainbow. Okay, the way you would write it, if its absolute value of n is less than 3, one way to change it is to just go -3 less than n less than 3. So again, an and problem, you're going to combine it, and you can see how it turns out, and you put the rainbow in between, just like how we did before when we just solved and problems before. Okay, the or problems, if its absolute value is greater than or equal to 3, what this is saying is all numbers greater or equal to 3 units from 0. Okay, so what that would be is 3 units from 0, and because it's an equal, I'm going to close my circle, or farther. 3 units from 0 or farther. And if you remember when we solved the or problems, our or graphs went outwards. Okay, so when you write this one, you can combine the and problems if you remember, but when we did the or problems, you could not combine it. You have to split it. So when you have this, you're going to split it, and you just rewrite this one exactly the same, but without the absolute value. And when you do this one, you're going to go opposite. If you can see, it's going to be less than or equal to -3. Okay? And you need to put the or in the middle. You have to have that. Okay? So once again, you drop it down exactly the same without the absolute value for this side. And on this one, you flip the sign and you add a negative. Okay? And that's how you do those. I'm going to do some more problem examples of both the and the or coming up. So you will be able to see them as we go. Okay. So first is the and problems. And I have them here. So the absolute value less than whatever number is going to be your and problems. Okay. And I can see that I got some glare, so let me change the lighting. Okay. So over here, in the same way with the equations, absolute value equations, you need to isolate the absolute value. So what we need to do here is -4 from both sides, -4, and again, if you want to draw that line, you can, and you end up with the absolute value of n is less than 5. Okay. When you write your answer, in order to drop the absolute value off, again, you just add in the -5 here, less than n, less than +5. Okay. So you go from this absolute value less than, you drop the absolute value, and you can add the less than -5. Okay. If you graph it again, really quick graph: 0, 5, -5. Because it's less than, it's open circles with a line in between. Okay. Here's another one. If I have this, I'm going to solve it by, I need to add 2 first. So I end up with 3, absolute value of n, and I'm going to put this on, is less than or equal to 12. Divide by 3 to get rid of this. Divide by 3, and I get absolute value of n is less than or equal to 4. Okay. Same thing now. I'm going to put the -4, less than n, less than or equal to, +4. And there's my answer. Again, the ands you're going to combine into a combination compound inequality. When I graph it, 0, 4, -4, close circle this time with the line in between. Okay. The next one, now I'm going to have n minus 3 in the absolute value instead of just n. Okay. So in that case, because the absolute value is already isolated, I can add this in, drop the absolute value, and go like that. Okay, so in order to drop the absolute value, I need to add in the less than and the negative 7. Now I solve it like we did in the previous section. You just add 3 to both to get rid of that. This becomes negative 4, less than n, less than 10, 10, negative 4, open circles with a circle in between. Okay, so pretty simple there. Here's another one with a binomial again inside the absolute value, but I have a 5 outside of it. So I need to divide by 5 first to get rid of this 5. Divide by 5. Then I get n plus 2 is less than or equal to 2. Okay, please don't just go straight to this. I want to see you go from the absolute value to this step. Okay, so from here, then I add in the negative 2 less than or equal to n plus 2 less than or equal to 2. Okay, so you should have this step where you isolate your absolute value, and then you can show this shortcut. Okay, then I minus 2 from all of them, and I'm going to get negative 4 less than or equal to n less than or equal to 0. I can put my 0 here, my negative 4. I can put a positive 4 if I want to. Close the circle, and a line in between the two. Okay? And that's how you do the AND problems. So I just showed you a shortcut. Once you isolate the absolute value, you can add in the less than and the opposite of whatever this number is. So if it's positive 5, you add in a negative 5. If it was a 7 here, you add in a negative 7. Over here I had a 2, so I added in a negative 2. Okay, so that's how you do AND problems. Next one we're going to do some OR problems. And the board is split, so I need to try and get this way. Okay, so you can see it's going to be absolute value is greater. Again, absolute value is greater than a number. That's going to be an OR problem. And if you remember the OR problems, your graph goes outwards. Okay. The OR problems, again, if you remember from the other section, you cannot combine these either. You have to write the word OR in between. In the same way, we need to isolate our absolute value. So I'm going to plus 2 to both sides. I'm going to get the absolute value of x is greater than 9. Okay, once you have a greater than, you have to split it. Just like how we remember when if it was an equal sign, we went x is equal to negative 9, x equals positive 9. Okay, in the same way, you're going to split it. But this time you have to leave the sign. Okay, so it's going to be greater than. We're going to split it. The first one I'm going to do is take the same inequality, so x is greater than 9, put it there. Okay, and then I need to go this side, and I need to put the opposite, like we did in the other example. So it's less than negative 9. If it was greater than 9, on this one I got to go less than negative 9, and I need to put the or in between. And I cannot combine my answer. Okay? Do not try to combine your answers. Do not try to go 9 less than x, like that, or even try to combine it. If you try to combine it and you have different signs, it doesn't work. Do not do that. Okay? So leave it separate. And when we graph it, 0, 9, negative 9. This one would be an open circle going to the right, and this one would be an open circle going to the left. And again, OR goes outwards, so that you should remember that. Another way to look at it is all numbers greater than 9 units from 0. So 9 units greater than goes outwards. Okay? So here's another example. I'm going to minus 3 from both sides. I'm going to 4 absolute value of x greater than or equal to 12. Divide both sides by 4 to get rid of that. And get absolute value of x is greater than or equal to 3. I need to split it. So x is going to be greater than or equal to 3, or, and if you notice I have the or, okay, and then x is less than or equal to negative 3. It's going to be easier for you to write the less than on the left side, so that when you graph it, you can just graph the right side and the left side here. Okay, so this one is going to be a closed circle going to the right, and this one is going to be a closed circle going to the left. Okay, so I'm trying to make it easier for you guys. That's why I said to do the greater than to the right and then the less than to the left. That way your graphs will be easy. Okay, so I have another binomial here. So once the absolute value is isolated, I can actually split it again. So this becomes x minus 2 is greater than 6. I wrote the same thing, just drop the absolute value, put your or here, and then when I do the x minus 2 here, I go less than negative 6. Okay, so you can see I flip the sign and I put a negative. Add 2, and I get x is less than negative 4, or, and I'm dropping it out, add 2, x is greater than 8. So when I do this, I get a 0 here, I get an 8 here, and I get a negative 4 here. Open circle going to the left, open circle going to the right. Okay. This next one I have a 7 outside of it, so I need to divide by 7 first. And I'm going to get absolute value of 2x minus 1 is greater than or equal to 3. Okay, I want you to show that where you isolate it. And then once you isolate it, now you split it with an or. Okay, so 2x minus 1 is greater than or equal to 3. We write the same inequality. And on this side, 2x minus 1 is going to be less than or equal to negative 3. I'm going to plus 1. 2x is less than or equal to negative 2. And divide by 2, so x is less than or equal to negative 1. Drop this down, and don't forget, that's a common mistake people make. They forget to drop the or down. Okay, so make sure you drop the or. Plus 1 to both sides, I'm going to get 2x is greater than or equal to 4. Divide by 2, and x is going to be greater than or equal to 2. And there's my answer. Okay, and then if you wanted to graph it, pretty simple. Put the 0, put the negative 1, put the positive 2. Closed circle going to the left for this side. And this side is going to be a closed circle going to the right. That's how you solve OR problems. So again, if you remember, please remember, and problems, once you isolate it, we drop in the make sure you keep your signs going the same way and then drop in the negative, the opposite of this, and you can combine it and it should be a rainbow in between. OR problems, once you isolate it, you need to split it, keep this the same, and then flip the sign and put a negative on this side, and make sure you put an or in your answer. And on or problems, your arrows go outwards because your distance is greater than that number. Okay, so here's a couple examples. So this is an example of a change. Okay, so I wanted to show you this. In this case, when I have this, I'm going to minus 4 from both sides first, and I'm going to get negative 3 m plus 2 is greater than negative 18. And I'll color code this for you guys. Okay, now I'm going to divide by a negative 3. And if you remember, when you divide by a negative, you need to circle and flip. So now my greater than actually becomes a less than problem. Okay, and then this is gone, and I'm left with m plus 2. Okay, and this becomes positive 6. So I went from a greater than to a less than. So I went from an or problem going to a and problem. And because I have an absolute value isolated with a less than, I can just change this to this. And then I can minus 2 from all three. And I would get negative 8 is less than m is less than 4. Okay, so you can see I went from an or to an and because I divided by the negative. Okay, a quick reminder, if you ever come out to absolute value is less than a negative number, that's saying what is less than 3 units, less than negative 3 units. Okay, and so that right away you should know that the answer is going to be no so. And what is greater than negative 7 units? Nothing. You cannot have negative units away from a number. Okay, so if you ever isolate your absolute value, whether it's equals, less than, or greater than, if it's ever a negative, you cannot have a negative distance, therefore it's always going to be no so. Okay, so homework check number 1 is here. Absolute value of x plus 6 is less than 1. Okay, the secret word, I'm not going to write it, I'm going to say it to see who's listening to my video and not just watching it. The secret word I'd like you to write is secret. Okay, I want you to write secret. So somewhere on your homework, when you solve this, I want to see the word secret. Okay, if you don't have the word secret, I know you weren't watching and I will not count. Okay, so the last part of this section is going to be real world problems. Okay, and real world problems are going to be and problems. Okay, but before I show you how and all that, I want to show you why. So if you remember in the beginning, we had absolute value of x is less than 3. What this was saying is between -3 and 3, and there's all units less than, all numbers less than 3 units, I'm sorry, it was off of this 3 from 0. Okay, if we do this problem, and I put a -4 less than x minus 2 less than 4, and I add 2, add 2, add 2, I would get -2 less than x less than 6. If I were to graph that here, 1, 2, 3, 4, 5, 6, and 1, 2, here's my 0. Here's my -2, here's my 6. Okay. What this is saying is actually it's 4 units from 2. So you can see from here it goes 4 units that way, 4 units that way, it's within. So it's all numbers less than 4 units from, and here's the key part, it's the 2. It's, even though it's a -2, it's from 2. Okay, so if I had this inequality, x minus 5 is less than 7, it would be all numbers less than 7 units from 5. Okay, it's from 5. If it was from here, it would be from -5. Okay, so it's opposite of whatever this sign is. So this would be 7 units from 5. This would be 7 units from -5. Okay, so that's where this is coming from. And that's a shortcut to what I'm going to be showing you here. So, if you worked at Nike and you're making hyperdunks, and the hyperdunk shoes, their shoes, by the way, basketball shoes, weigh 24 ounces, and the manager told you at most it can be 0.5 of an ounce off, half of an ounce off. How do you write that compound inequality? Well, according to this, you would just write it this way. You'd go absolute value of x minus 24 is less than or equal to, at most means it can be at most, and I can see that I'm writing off of this, 0.5. Okay, and that's how you write the inequality. It's 0.5 or less away from 24. Okay, when you want to find the exact acceptable range, you just put the -0.5 less than or equal to x minus 24 less than or equal to 0.5. When you plus 24 to both, or I'm sorry, to all three, you get 23.5 ounces less than x less than 24.5. So you can see it went up 0.5 of an ounce and it goes down 0.5 of an ounce. But that's how you do those real world problems. Okay. You can also look at the book for another example. So here's homework check number 2. And sorry, I know there's that glare. So it's 3 times absolute value of x plus 4 is greater than 15. Okay, please solve it. And I do want you to graph it. I'm sorry, I want you to graph both of them. Okay, please solve and graph. So I'll even write it again. Solve and graph. Both. Homework checks. Okay, so please solve and graph both homework checks. Okay, and don't forget the secret word is secret, so you have to have that written somewhere. Okay, hope this helps. Take care. Bye.